what we're going to talk about is polynomials. Tell me what a polynomial is. Can you give me an example of a polynomial? That's a polynomial. Just a combination of letters and numbers. It can be different powers. Okay, this is a polynomial. You've had this, okay, so this should be just review. This is a 4-term polynomial, okay, because it's separated by either addition or subtraction, 4 different spots, okay? Now, classifying polynomials, the very first classification is a monomial. Give me an example of a monomial. There's one. Okay, here's another one. Okay, here's another one. Basically, a monomial has no addition or subtraction in it. Okay, that's what I know on a monomial. The addition and subtraction separates it in terms. So a monomial has 1 term. There's no addition and there's no subtraction in it. Okay, this is also, that's a monomial. Okay, so I can't say that there's no division or multiplication. Understand each one of these are multiplied. So it can have multiplication in it, it can have division in it. Okay, but it cannot have addition and subtraction because I have to have it just be 1 term. What do you think a binomial is? 2 terms, okay? A bicycle, you know, it has 2 wheels to it. How about a trinomial? 3 terms. Now what happens after you get to the 3 terms is they classify everything after that as just a polynomial. Okay, now, truthfully we could go, oh, 4 terms should be a quadnomial. But nobody ever calls it that. So these are all polynomials. They can all be just called polynomials. But after you get to the 3rd term, they definitely are all called polynomials. Okay, so this one has 2 terms. You can just call it a polynomial or you can call it a monomial. All right, so when we move past 3 terms, though, all we call it or all we classify it is a polynomial. So what we're going to do is this chapter is going to be doing math on these polynomials. We're going to be doing addition, subtraction, multiplication, division. Okay, and there are certain rules that we have to follow for these. Like for instance, well, first let me just show you, and we're not going to spend a lot of time on this, but just to refresh your memory. This is something that you probably have seen in science. Does that look familiar? Okay, scientific notation. Now, scientific notation kind of messes me up because remember they say don't use X anymore for multiplication? But then scientific notation comes along and what do? They put the X back in there for multiplication. And you, no matter what level of math you're at, when they write something in scientific notation, they use an X. I think they do that so the dot doesn't get mixed up with the decimal. Okay, I think that's why they do that. Now, if I'm going to do, this is scientific notation. This is 2.35 times 10 to the 4th power. If I asked you to write that in standard or decimal notation, standard and decimal notation are the exact same thing, okay? What would that be? How am I going to do that? Joseph, how am I going to do it?
I don't remember if you want.
I bet you remember, you just don't know how to put it in words. What if I said, that's it right there. I moved the decimal. That's how complicated this is. That's really not at all. I know that that's going to make this a bigger number. That positive number up there is going to make it a bigger number. So I'm going to move the decimal to the right, which is going to make it bigger. So I move it 4 places to the right. 1, 2, 3, 4. Okay? And it becomes that number.
If it's negative, you go to the left.
If it's negative, like for instance, good question, Reagan. If it's a -4, I know it's going to be a smaller number. So I'm going to move it that many places to the left. So I would move it 1, 2, 3, 4 places to the left. What's going to go in all of those spots?
2.
0. Placeholder zeros. Okay, 1, 2, 3, 4, and that becomes my number. Okay, now you have to be able to go back and forth between scientific notation and decimal notation. So these were going from scientific notation to decimal or standard notation. So let's practice that for a minute. Let's say I have this nice long number. I don't know why I stick to the 2. Why is decimal notation, why was scientific notation invented?
Long numbers.
Yeah, absolutely. In life, especially in science, there's some very, very long numbers. So it's a shortcut in how to write those numbers, okay? So I got to do some counting here, okay? Now it's easier if I'll go ahead and put the commas in there, because then I know every set of commas is 3. So remember, my understood decimal is right there. Now this is a really big number. So this is going to be a positive power, okay? So I have 3, 6, 9. Where do I want my decimal?
After the 7.
After the 7. Remember, it has to be written as a number between 1 and 10, and then a power of 10. So 3, 6, 9, 10, 11. So I have 7.1654. Don't have to include any of those. Times 10 to the 11th power. Okay? Y'all remember doing this, right? Okay. This should just be review. Don't think that there's a big issue here. All right, let's do one last one. Let's make a really small number. All right, where does the decimal need to go?
Between the 7 and 1.
Between the 7 and the 1. So I've got to move it to that location right there. Okay, because it has to be written as a number between 1 and 10. So I count. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 1.14 times 10 to the negative 9th, though. Remember, this is a really small number. When it's a really small number, it's going to be negative. Okay, y'all remember all that. Okay, that's just a blurb at the beginning. All right, let's go back to our monomials here. What if I have that? Okay, those are both monomials, right? In fact, this whole thing is really a monomial. So how do I multiply those two things together?
Add the powers.
I add the powers. So this is x to the 10th power. These are called base numbers. When the base numbers are the same and you're multiplying, you just add their powers. If the base numbers are numbers, let's say I have 2 to the 4th power times 2 to the 10th power. I can do the same thing because the base number is the same here. So what is the answer to this?
2 to the 14th.
2 to the 14th power. All I'm going to do is I'm going to add their powers. Okay? Now, what happens if the base numbers are not the same? Let's say that's a y. Now what do I do? Absolutely nothing. Okay? Yeah, I can recopy it and just leave out that dot in the middle. Okay, but that's the same thing as saying x to the 4th times y to the 6th. I can't combine those. Those base numbers are not the same. I cannot put them together. All right, what about this one? See what you guys remember here. A power raised to a power. How do I do math on that?
Subtract. Or you multiply. I forgot.
Go with your second instinct. multiply. Okay, multiply, because really, okay, if we wanted to take the time to work this crazy thing out, what it means is x to the fourth times 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 x to the fourth. How many do I have? That's 5. One more. Times x to the fourth. Okay? Now, personally, I don't want to do that. Okay? But then I would add 4 plus 4 plus 4 plus 4 plus 4 plus 4. Easier way? If I have a power raised to a power, let me just multiply. That's going to give me x to the 24th power. If I added all those 4's together, that's what I would get. Okay, you can do it the long way. Just keep in mind what it's meaning. Okay? You remember this? Sort of, kind of? Okay, what about this one? I think in Algebra 1, like, they give you like a whole section on each one of them each day, but those days are done. What about that? Reagan, what was your first instinct on the other one? Subtraction. Okay. If I have division where the base number is the same, all I do is subtract. Now, another way of looking at this is I subtract and I put it in the position where the highest power is. Okay, the only reason why I'm saying that, the highest power here is on the top, right? So I can go, oh, that's over 1, but of course I don't have to put it over 1. What if I switch these two? Now what's my answer? 1 over x squared. So this is what I've done, is I've said 6 minus 4 is 2, but the highest power is on the bottom, so my x squared is on the bottom. If you remember right, when you learned this, you might have written it all out like this. And you go, those partner up and leave, those partner up and leave, those partner up and leave, those partner up and leave. I've got 2 left and they're on the bottom, so I've got to put a 1 on top. Now you're not going to go to that trouble every single time, but that's the logic behind it. That's why it works like this. Another way of doing this, you might have learned it this way. 4 minus 6 is negative 2. X to the negative 2 power means that I'm going to put it on the bottom because this is on the top. So that's the same as x squared. Okay, we worked with that too. So you have some negative exponents. They're all the same thing. You have to logically remember what we're talking about. Okay, so whichever one of those makes sense to you, do it that way. They're just different methods. All right, I'm going to give you one to try, just on a piece of scrap paper, okay? Then we're going to combine a few things, of course. Okay, we'll start out simple, okay? So give me an answer to that. You can use your calculator to find out that one, or you could have just written it. Oh, I don't know why I did. Okay, let me change that to a C. I don't know why I wrote that like that. Wouldn't have made any sense. Oh, that's what you have, okay? Because the 3 is applied to each individual item in here. Okay? Does that make sense? All right.
Because the B would have been 12B.
Yes, if I had left it like that, yes, yes. All right, let's look at this one. Okay? Several different things going on in this problem, so be careful. Oh, wait a minute. Let's make it even more complicated. Okay, that's a power right there, a 3B power. All right, give that one a shot. Looks very impressive. I haven't put an answer up there yet. There's two different ways you can do this. All right, I'm gonna stop this and restart it so that it doesn't cut off in the middle.